Hello IB. Today we're looking at 10C, which is modelling using sine functions. Now we've already probably looked at this opening problem, but just a quick overview. This is the Ferris wheel. So because we see it's a periodic function, so we can see that the height above the ground is continually changing and repeating as it goes round and round. So we see that it takes 12 units of time. So up to 12 is one full cycle. So it goes up to the maximum height of 22 because the radius of the Ferris wheel is actually 10 metres. So that's a length of 10. So that's 10. So it goes up 10 and down 10. And this gap down here is 2 metres. So we can model this using our sine function, starting at 12 in this position, 2 plus 10, going up to 22, down to 2 when it's at the bottom, and then back up to 12. So that whole time is 12 minutes. So that's just a fairly typical example of how we use the sine curve to model a real-world situation. The two other examples that the textbook has, this has got the data for Cape Town, so you may have looked at this, looking and seeing what happens to the temperatures. So here are the temperatures for one whole year, and then they've plotted this data. And we can see here a principal axis, so we can go through and let's just clear all this out now. So we can put a principal axis in, and to find your principal axis, you need to take your maximum minus your minimum, and then divide that by 2 to find your amplitude, or you can do 15 plus the maximum, 15 plus 28 over 2 to give you your principal axis. So that's our D value. So at 21.5 is our principal axis, then it goes up 6.5 units and down 6.5. So the 6.5 is our A value. The D value, as I said, was 21.5. We then need to think, if we're going to plot it with a sine curve, we look for the principal axis where the curve is passing it. So this is our first point of intersection, and we can see that the data goes down from this point. So that means we've got a negative sign, because positive sign starts on the principal axis going up, like over this position. If it starts on the principal axis going down, then it's a negative. Our C value is a shift, so we've got to think how far has it shifted across. We obviously can't just, we've got January, February, March, etc. plotted on there for time, but for an equation we can't have words, we need to put those into numbers. So therefore each month becomes a number, so January becomes month 1, March is 3. So if we look and see where that shift is, it's happened in April, so we call that 4. So our C value is 4. The last thing we need is the B value, the period. So if we're working in radians, then we're thinking 2 pi over the B value, or in other words, B is 2 pi over the period. And our period is 12. So therefore our B value becomes pi on 6. So overall our equation then becomes T, the temperature, is equal to a negative, because it's a negative sine graph. 6.5 was the amplitude, sine of brackets, pi on 6 is our B value, open a new bracket for the T minus 4. So always have those double brackets so that any translation is separated from the B value, which is to do with the period. And at the end, plus 21.5, which is our principal axis. So if you put all the data into your calculator and then plotted that curve, you'd see it lies very closely to the data we've got. Just want to point out a couple of things in the other example in the textbook, so probably no need to write this all out. First thing is that sometimes when in real life the period is not always constant. So the period, the time between highs or the time between lows. So this data here is for tides. So the tide is high at these particular times. So we see that the time here isn't always the same. So that period, or the time between those two highs, is not the same. The time between the lows should also be matching. So we've got 5 different values here. So what we need to do is account for that and take the average, because, as I said, in real life, it's not always perfect sine curves. So take the average period, and that comes out at 12 hours and 24 minutes. So again, we can't just put 12 hours and 24 minutes into our equation. You need to turn that into a decimal number of hours. So T is the time in hours. All right, so we want that as our units for time. So 24 minutes, 24 out of 60 is 0.4. So you'd put your time in as 12.4. So now to get your B value, it's going to be 2 pi divided by 12.4. And then come out, either put that in as is or else in your calculator and round it to 3 significant figures. From then on, the rest of the proceeding is much the same. You've got the high tides, and so getting those maximum and minimum to get your principal axis. And so you come out with, that's to get the shift at least. So you come up with your equation. So let's just look at that shift. So the shift here is x. So at that time is where it's crossing over the axis. So it's a matter of trying to turn that time into a value instead of going at a particular time. So the first minimum was at 6:46 a.m. The next maximum was at 1:18. So they've just taken the midway point between those two to see when it's on the principal axis. So that's midway between 6:46 for the first low tide and then the first high tide. After that was 6:46 a.m. That's the low tide, and then the high tide was at 1:18 p.m. So that's where they've used those two values to come out with the time to get the shift. So again, they've turned these values into a decimal. All right, so 6:46 a.m. is like 6.77 hours. And the one, let's put that in a different colour here, the 1:18 has been turned into 13.3. All right, so in real life we need to make those adjustments. So your equation ends up with that shift of the 10.0, and that's your period that we calculated earlier. So this one we'll work through in class, and this last example, have a go at coming up with 2 sine equations for this. So look and think through the amplitude, your principal axis, the period and the shift. Note the scale is 6, which means we're in radians, and think the 2 pi is approximately equal to 6.28. Let's do an approximately there. And if you can come up with 2 equations that are correct, you might just earn yourself a Freddo frog. So come to class and tell us what you found out. Thanks for listening, and bring any other questions you might have as well. Bye for now.